Welcome to Calculus Homework, page 287. We're going to be working with this implicit function. It's implicit because it's got x's and y's all mixed together. There's no way we can solve it for just one simple y. So it's an implicit function because y is mixed in with all the x's. You got y squares, different powers, all that. And we're going to be working with this. Probably it might be a good idea to go ahead and graph it and see what it's going to look like. Let me show you how to graph it. Okay, I'll need you first of all to be looking at this equation. Let's go to our calculator and click the little house, tell it you want a graph. Now, the way that you graph this is, first of all, to graph an implicit function, you need to start with the word zeros. There is no key for that. You'll notice that is not the way we normally spell zeros. Zeros is normally spelled Z-E-R-O-E-S, but that's the way we're going to spell it when we're graphing implicit functions. The next thing you do is you put a parentheses and you type the problem. If it's already solved for 0, which this one is, if you look at your sheet number 5, it's already solved for 0. So let's type it in 4x squared plus y squared minus 8x plus 4y plus 4 is equal to 0. Now we're going to put a comma and tell it that we are graphing this function implicitly for y. If we hit enter, we get an ellipse. I'm going to copy this back to our page so that we can work on it. So this is what it's going to look like. I want to know where it'll have a horizontal tangent. Just looking at the graph, we can tell that there's going to be a horizontal tangent right here and also right here. And that looks like it's about where x equal to 1. Of course, we have to do this analytically for calculus. So let's go ahead and solve it using our calculus now. So the answers, once again, we think are going to be here and here, and that's where x equals 1. All right, let's begin. Since they say a tangent, okay, that's code word for take the derivative. So that'll be 8x plus 2y derivative of negative 8 plus 4y derivative. The derivative of that 4 is 0. The derivative of 0 is 0. Okay, our next step will be to solve this for y derivative. We need to move everything else to the other side of the equation. So let's add 8 to both sides. Subtract 8x from both sides. That will give us 2y derivative plus 4y derivative equals to 8 minus 8x. Over here we have y derivative in common. We also have a 2. That will leave us with y plus 2 and here I might as well go ahead and factor. That's going to be 8 times 1 minus x. On the bottom, I just want y derivative, so I'm going to divide both sides by 2, and then y plus 2. So we get y derivative, because that's going to all cancel. 2 goes into 8 4 times. So that's going to give us 4 times 1 minus x over y plus 2. That is the equation for the derivative of this function. Okay, our next step is we want to know where this has a horizontal tangent. Okay, at the horizontal tangent, we know that the derivative is equal to 0. So we want to know where this derivative would be equal to 0. We also know that whenever we have a rational expression, it's the numerator. When the numerator is 0, the rational expression is equal to 0. Some people think when the denominator is 0, they have a horizontal tangent there, but actually, if the denominator equals to 0, that's where the function would not exist. That's where you would have vertical tangents. So we want to know what would make this equal to 0. Well, let's see. Well, it can't be the 4. We know that right here, if x was equal to 1, you'd have 1 minus 1, 0. 4 times 0 would be 0. If x, all right, so 0 over this. So the answer is that x equals 1. So you have a horizontal tangent when x equals 1. So we're looking for 1 something. It said find the coordinates of the points, so we need to find the y-coordinate also. Well, that was the graph of that function. We know that we're going to have horizontal tangents when x equals 1. So we can go back and we can take this equation and we can plug in 1 everywhere we see an x and solve this for y. So if we plug in 1 for x, that'll give us 4 times 1 squared. That is 4 plus y squared minus 8 minus 4y plus 4 equal to 0. Now we can combine our like terms. 4 minus 8 is negative 4. Plus 4 gives you 0. So 4 plus 4 is 8. Minus 8 is 0. That leaves us with y squared minus 4y equal to 0. To solve this, we can factor out y. That'll leave us with y minus 4. That should not be there. And we know that we'll get 0 and positive 4 for our answers. So this is telling us when y is 0, we have a horizontal tangent, and we can see from the graph at 1, 0 there is a horizontal tangent. We also can see that when y is, that should be a positive 4. My apologies. See, that was plus 4 there. So let's change that to plus 4y. That means when y is negative 4, when x is 1 and y is negative 4, we also have a horizontal tangent right here. Okay, so those are our answers. All right, if we go back to that derivative again, this is the derivative of that. We want to know where we have a vertical tangent. Okay, we know that we have vertical tangents when the denominator is equal to 0. Okay, that's when here y would be equal to negative 2. And if you look here, when y is -2, there is going to be a vertical tangent there. Also, look, there's going to be another one there because there y is also equal to -2. So it's going to be something -2 and then something -2. Okay, we need to find out what that is. All right, so first of all, let's take our equation again. This time we're going to plug in -2 for y. It's just going to give us 4x squared. -2 squared is +4, minus 8x. Positive 4 times -2 is -8, plus 4 equal to 0. Combining like terms, positive 4 minus 8 is -4, plus 4 is 0. So that 4 and that 4 gives us positive 8, -8 is 0. We're left with 4x squared minus 8x equal to 0. We can factor out a greatest common factor of 4x. And that's telling us that we're going to get 0 for an answer and also 2 for an answer. So at 0, -2, and 2, -2, you'll have a vertical tangent at 0, -2, and also another one at 2, -2. So those are our answers. Okay, let's look at number 7. This time they want the equation of a tangent line and the equation of a normal line drawn to this curve at this point. Let's go ahead and graph it on our calculator to see what we're looking at. So first of all, we need to solve it for 0 because we're going to be doing zeros. So we're going to subtract 5 from both sides. And when we do that, this is what we'll put in the calculator. So on our calculator, let's have it do a new graph. And let's type in zeros. X to the 2/3. Let's see if I need to go. Plus y to the 2/3. And since we're graphing zeros, we need to make that equation equal to 0. So we subtract 5. That would make it equal to 0. Then a comma. And since this is an implicit function, we need to tell it it's implicit for y. We hit enter. Ooh, we get this graph. Kind of like a diamond shape. I'm going to copy that to our screen so that we can talk about it some more. You notice a lot of these implicit functions, they're really not functions as we've talked about before, because remember the domain is used way more than one time. Okay, I'm going to shrink it up a little bit and just move it over here. Okay, we want the equation of the tangent line at the point 8, 1. If we just look at the graph, 4, 5, 6, 7, 8, 1, that's that point there. We know the tangent line would be like that. Just looking at it, would we expect a positive or a negative slope on the tangent line? Since the function is decreasing there, we know that'll be negative. Okay, so let's go ahead and do the work now. All right, and anytime they say a tangent line, we know automatically to go ahead and take the derivative. So let's take the derivative of the function. So it'll be 2/3 x negative 1/3 plus 2/3 y to the negative 1/3 times y derivative, since we're doing implicit for y, equal to, and the derivative of 5 is 0. We need to solve this for y derivative. So let's go ahead and move this to the other side. This is 2/3 y to the negative 1/3 y derivative equal to negative 2/3 x to the negative 1/3. Divide those sides by 2/3 y negative 1/3. This is all going to cancel. We're going to get y derivative equal to, the 2/3 canceled, which is nice. We've got negative. Notice that these are both negative exponents, but if we flip them, we get y to the positive 1/3 on top, x to the positive 1/3 on bottom, or a better way of saying that is cube root of y over cube root of x. So that is our derivative. Now they want the equation of the tangent line. We want the equation of this line right here. So what we're going to do is we're looking for y equal mx plus b. They tell us the point, so we don't have to go looking for that. We can go ahead and plug in that value for x, that value for y, and that will tell us the slope of the tangent line. So y derivative is negative cube root of y over cube root of x. Y is 1, x is 8. Cube root of 1, cube root of 8 is 2. So our slope of our tangent is negative 1/2. That makes a lot of sense because we can tell the function is decreasing there, and that little tangent would be negative. We also need to know the y-intercept. If we were to extend this, what would the y-intercept be? So we need to find b, y equal mx plus b. We just found out the slope was negative 1/2. We also know that x is 8 and y is 1. We have negative 1/2 times 8, which is negative 4. We add 4, and we get b equal 5. So the equation of the tangent line is negative 1/2 x plus 5. Okay, we're going to do part 7b now, the equation of the normal line. In the previous step, we found out that the slope of the tangent at that point was negative 1/2. We are now looking for the slope of the normal. We know that that would be this line here, and we want the equation of that line that is perpendicular to the tangent. We also know that the equation of the normal line, the slope is perpendicular to the tangent, so perpendicular to negative 1/2, opposite reciprocal is 2. So now we just y equal to 2. We can plug in our values of 8 and 1, we get 1 is equal to 16 plus b. We subtract 16, and that gives us b equal negative 15. So the equation of the tangent line is y is equal to positive 2x minus 15. So that's the equation of the normal line. Just looking at our graph, we can tell that that line would be increasing with a slope of positive 2. We can also tell that the y-intercept would be way down here at negative 15. All right, that concludes page 287. Thank you for watching.